Suppose sweep line is here. There are some sites above. Okay, let's take a 3 sites. So this is the coordinate diagram, whatever is looks like. So we don't know this. What are the sites below this one? So there may be sites immediately below the current sweep line. So we indicate this part of the off plane which is above the sweep line. Suppose this is L, I will indicate this area by L plus. Okay. So here these sites here, in this case it's not a problem. Okay. So this particular vertex is defined by 3 sites which are above the sweep line. We already know all these 3 sites which is defined this coordinate. In this case, it's not a problem. But there could be some site here immediately below, and the bisector between them, okay, is something like this. So after this, bisector between these two will start. Okay, so this will become a bisector. So let's name them 1, 2, 3, 4, and this is the bisect between 1 and 2. And from here onwards, the bisect between 3 and 4 starts like this. You see? See, because of the side 4, the Warner diagram is changed. So everybody able to see this one?
Yes, sir.
Is it clear?
Yes, sir.
So why we cannot compute the Warner diagram up to the current position of the sweep line? So what we will do actually is, but if you look at this one, suppose take a point Q. So even though the site 4 is coming up immediately below this sweep line, the Q still belongs to this site 1 itself. Yes. Similarly, this point, suppose you take a Q here. For this site, this point Q, the site is 2 only. So still it belongs to this corner region of 2. Okay. So this point is not affected by the some sites which are below sweep line. Only, see, if you look at this one, only points here about below this red line is changed because of this site 4. Of course, there could be another site somewhere here. We don't know. Okay, maybe it's a 5. So things will change once again. But as of now, this L is here. So just assume that this 5 is not there. Okay, and this 4 is immediately just about to touch this site 4. Okay, so all the points below this red line is going to affect it. All the points above this red line not going to affected by this site 4. Agree? Yes.
Yes, sir.
So there could be this new sites which are coming immediately below this line, can be anywhere. So we are discussing only with respect to one particular site 4 here. Okay. So now what we will see actually is which part of the Warner diagram in L plus, that above line sweep line L, is not going to affect by any site below L. See, if you take this example here, this Q here, and Q here. These 2 points still corresponding to the Warner region of the site 1 and 2 respectively, irrespective of the new sites encountered immediately below the sweep line. Okay, that means some part of the Warner diagram is not going to affect by the sites below the sweep line. Agree?
Yes, sir.
So, what is the locus of all such points? Okay, now you'll take it actually. Well, let's take a one simple site. This is the site 1 and this is the sweep line here. And there could be some sites below this one. We don't know where exactly is there. Just immediately below this. Okay. For which points we can surely say that closest site is 1, not any other site below L. You are able to see this? So we want to see which points are closer to 1 than any site below L. See, as of now, we are assuming there is only one site above L. So all other sites are below. We don't know exactly where these other sites are there. But, okay, which part of the Warner diagram not going to affect by sites below L? In other words, which points are closer to 1 than any other site? Suppose you take this one, Q. This is closer to this one than any site below L. That means if you take this perpendicular distance here, okay, so this distance must be greater than this distance. If this is satisfied, okay, all those points we can say that actually this is closer to the site 1 than any other site below this one. Locus of all points which are closer to 1 than any site below L is the, for which we can surely say that for that region we know this Warner diagram. So that part of the Warner diagram not going to influenced by any site below this one. Or in other words, locus of all points which are closer to 1 than any other site below L, are all the points which are closer to 1 than this line L itself. Since we are taking the perpendicular distance, okay, all the points are closer to 1 than this L. So that is nothing but a parabolic arc which passes through the middle point, something like that. It will be like this. Okay. So for all the points on the parabola, this distance is same as this perpendicular distance. So this distance is same as this distance. So some point inside the parabola means this point is closer to this side than this line. In other words, any side below this one. Is it clear?
Yes, sir.
So what about others? Only you are responding. What is your name?
Saket Kumar Singh.
Huh?
Saket.
Saket. Third year.
Yes, sir.
Anybody else is there listening?
Yes, sir.
Yes, sir.
Is this point is clear?
Yes, sir.
Yes, sir.
So this is very important. So inside this parabola, Warner diagram not going to affect by any side below this L. Agree? Now let's take another site. LS2 here. Assume that 1 is not there. For 2 also there is one parabola is there. Okay. Parabola is something like this. Okay, I'm drawing this parabola approximately. Okay. You remove all these things. Okay? Agree? So we are assuming that 1 is not there. You consider the parabola corresponding to 2. Same thing we can say about all the points in the parabola 2 also. Suppose if you consider 1 and 2, both of them. Let's take the union of these two parabolas. Okay? So this point here, intersection between these 2 points, okay, which is on both the parabolas, that means this distance is same as this distance as this distance. So all the 3 distances are same. Basically, this intersection between these 2 parabolas is a vertex on the bisector between this 1 and 2. Okay, this is bisector. Are you able to see this one?
Yes, sir.
So if you take the union of these 2 parabolas, so that is basically this region. All the points above this, we know that actually, if you take any point Q, so we surely say that point Q is closer to some site, either 1 or 2, is closer to Q than any site below L. Yes? In this case, Q, in this example, the Q is closer to 1 than 2. Okay? In fact, each and every point above this union of these 2 parabolas, okay, if you take any point in this region, we surely know that actually which side is closer to this point. That point, those sides are above the L only. Those are not closer to any side below line, sweep line, or in fact actually to this sweep line. Yes?
Yes.
Okay. So we can take any number of sides above L. Okay, for each side there's a parabola will be there. So suppose if you take one more, okay, 3 somewhere here. And for this also there is another parabola will be there. Okay, so union of all these parabolas, if we take all points above this is closer to some side above L than the sweep line itself. So this intersection between the 2 parabolas traces bisected between 2 and 3. So what we understood is, if you have a sweep line at this position, some part of the Warner diagram not going to affect by any sides below L. So that region is nothing but a union of these parabolas. So this, what we call as a beach line. Okay, in the seashore, okay, in a beach, we'll see a waves coming, no? So union of these waves looks like this one. That's why he called as a beach line. And these intersection points, what we are between the 2 parabolas, are called a break points. See, this break points is not a coincidence. These break points are nothing but a vertices on the bisector between the 2 adjacent sides. Okay, so what we understood actually is part of the Warner diagram above this beach line, is not going to affect by any side below L. So we compute the Warner diagram up to this position. Even though sweep line is below this one, but we maintain the Warner diagram up to this beach line. So if you keep moving this sweep line below, and this beach line is also expands. So this basically traces out, and this is a traces out. Okay. In fact, actually it will be like this bisector. So this will be bisector here. Okay. So if this C plan is moving down, so beach is also coming down. So we are unraveling the Warner diagram from top to bottom. So we maintain this sweep line status as this beach line. Is this clear to everyone? What is the sweep line status? Sweep line status is nothing but a union of these parabolas. That's what we call as a beach line. Any questions till now? See, it is nothing difficult actually. See, very easy algorithm. Only thing is this concept you have to understand. So we cannot maintain the Warner diagram up to the current position of sweep line, but we can maintain the Warner diagram till this beach line. Locus of all points for which we can say that, okay, closest site to this point is something already we encountered, some site above L, but not any site below L. So those points, locus of all such points you take in that part of the region, we can compute the Warner diagram. That is not going to change by any side below the current position of the sweep line. So that is nothing but this parabolic union of parabolas. Okay, is that clear? So we call this as a beach line, and we maintain this beach line as a sweep line status. Any questions? So everybody convinced?
Yes.
See, once we know this one, other things are basically you have to work out. So when the beach line changes, when the sweep line status changes, you have to identify, and how to update you have to identify, and what are the data sections required to maintain the beach line, the sweep line status, and the event queue, all those things. That's all. Nothing else. Those are the details. This is the crucial part here. Of course, where this sweep line status, the beach line changes, we have to identify that also. Little bit of few things we have to work out. But remaining, this is the main crucial idea. Rest everything is one can work out. Okay. Now, when this beach line changes, those are we are calling as the events. Basically, when the sweep line status changes, that means beach line changes. Those are the events. So we have to update this. We have to know these events. We have to maintain these events in the event queue, and we have to process them in the order from top to bottom. Okay. Yeah. Let's see this one. Let's take another example with two sites. Say this is a PI. Okay, this is okay, PI, and this is PG. And sweep line is somewhere here. And if you take this parabola, locus of all points which are closer to just I'm taking the okay. Now assume that new site is somewhere here. What happens when the sweep line passes to this point? What is this parabola? Just crossed or just on this one. All the points which are closer to the PK than this line are this parabola. All the points which are closer to PK, then the sweep line L is nothing but this vertical line. Yes? All the points which are closer to PK, then this line is nothing but a vertical line here. Agree?
Yes, sir.
Now assume that the sweep line is moved a little bit below. So what is the parabola corresponding to this PK? It will be something like this. Yes?
Yes, sir.
So when the sweep line is at this site, PK, this parabola is a degenerating parabola which is simply a vertical line segment. This segment. Once the sweep line moves a little bit, and this point this parabola opens up a little bit, and this point moves in opposite direction. And this traces out the bisector between PI and PK. So initially this edge, which is a bisector edge between the PI and PK, is not connected with the rest of the Warner diagram. But eventually it will, when the sweep line moves further down, then it will be, the parabola becomes bigger and bigger, and it intersects with this one somewhere. Okay. So this parabola also moves, and this parabola also moves like this. Okay. So at this time, this bisector will meets with the rest of this one. Okay. Warner diagram what we completed. Able to see this one? So I'm repeating once again. Whenever sweep line touches a new site, PK, at that time all the points are closer to PK, then this line is nothing but a vertical line. Okay, so that immediately above the PK, this vertical line. This is a degenerating parabola corresponding to the site PK. And this point is on the bisector between PI and PK. When the sweep line moves downwards, this parabola opens up, and this point traces of the same, okay, moves into opposite direction, traces of the bisector between the PA and PK. So after some time, after this sweep line moves downwards, this line touches with the remaining part of the Warner diagram, touches with some other edge of the Warner diagram, where this edge is connected with the rest of the Warner diagram. Okay, so this is the way new site is, whenever new site comes into the picture, and this is what happens to this beach line or the sweep line status. So new parabola comes into the picture. So sweep line changes or a beach line changes at the new site like this. Is this clear?
Yes, sir.
Okay, this is what is called a site event. Site event is when the sweep line crosses the site, and parabola corresponding to the site is added to the current beach line. Okay, and where else this beach line changes, sweep line status changes? Can you think of situation where beach line changes, sweep line status changes? See, in this example itself, another event is going to take place. Okay, yeah, that we'll discuss at the next point here. Suppose there are three sites are like this.
Sir, when two junctions are going to meet, like one parabola will vanish.
Okay, so parabola corresponding to the PA is something like this, and parabola corresponding to PJ will be something like this, and parabola corresponding to PK something like this. Okay, so when the sweep line moves downwards, these parabolas also move downwards, and the middle parabola becoming smaller and smaller, and eventually at this point, okay, it will vanish from the beach line. So at this point, all the three sides, PI, PJ, PK, are equidistant. Okay, and not only that, this line, sweep line also are equidistant. So if you draw a circle passing through the PI, PJ, PK, whose center is this one vertex? Okay, and sweep line is at the tangent to this one. So all the four, the PI, PJ, PK, and this bottommost point of the circle, all four of them are equidistant from this Warner vertex. Yes, you are able to see this one?
Yes, sir.
See, this Warner vertex, we can see that okay, PI, PJ, PK are on the same distance. So on the circle. Are you sure that actually this bottommost point of the circle passes to this sweep line? Or if the circle is tangent to this sweep line at the bottommost point? Because that is true, because this point is closer to some site above than any site below this one. So exactly at that point, actually, it is tangent to this, the circle is tangent to this sweep line. So basically, disappearance of a parabola from the sweep line status or the beach line, okay, is an event. That event leads to a discovery of a Warner vertex. And this happens when the sweep line is a tangent at the bottommost point of a circle passing through three adjacent sites. Here in this case, PI, PJ, PK. Where the middle parabola corresponding middle side PJ disappears from the sweep line status. This is what is called a circle event. Okay, so this is the way parabola disappears from the beach line. So these are the two types of events. One is circle event, other one is circle event, site event and circle event. In the site event, new parabola comes into picture. New parabola comes into this beach line. At the circle event, some existing parabola disappears from the beach line. Okay. Is this clear? Any questions? Okay. The site event are known to us before, so we can no need to do anything, already given to us. Circle events we have to find out on the fly and we have to use them. Now there are a few points are there we need to discuss. What is the size, maximum size of the sweep line status? How many parabolic arcs will be there in the sweep line status in worst case?
N number of points.
Exactly n. It can be more than n. See, if you look at this diagram, this parabola and this part of these two parabolas belongs to the same side PI. And these two parts of PI side. Yes? So there can be two parts for each parabola in this sequence status, beach line. So in most case, size is 2n minus 1. Okay. So of course, this is a linear, so we no need to worry about that. Now, how to find out these circle events? The circle events we have to find out on the fly. Just like intersections between the line segments, we are finding on the fly. Somebody can think of something? How the circle events can be detected?
Sir, we can take 3 consecutive points at a time and compute their circumcenter.
Yes, that is true. Good observation. 3 consecutive points may define, okay, circle event. Okay. It is not guaranteed that each and every 3 consecutive sites in a beach line defines circle event. Why? Because suppose if you take example like this, okay. So in this case, it's not going to define. Because parabolas are something like this. Okay. Here, even though these three are 3 consecutive, the middle parabola is not going to disappear. It is expanding. Okay. How to eliminate such things? If you take the circle passing through these 3 sides, your sweep line is somewhere here. Okay. This circle is not intersecting the sweep line here, which is above this current sweep line. So if you look at, in this case, the current sweep line is intersecting with this circle here. Okay. So corresponding to this circle event, this is the vertex which is discovered actually. That event already taken place, we no need to worry about that one. So whenever 3 consecutive arcs are appearing, new existence is formed. So you find out this circumcircle, and if the circle is intersecting with the current sweep line, then in future this sweep line may become a tangent to this circle, so that middle arc may disappear. So in that case only we'll keep track of this event. Otherwise we won't keep track of it. Yes, clear? Okay. Is it clear?
Yes, sir.
So basically similar to this line segment intersection problem, whenever there is a change in the sweep line status, that a beach line, new consecutive 3 arcs appears whenever the new consecutive arcs, three arcs appears, okay. So in the case of a site event, Pi, Pk, and Pj are adjacent to each other. Okay, three different these things. At the time we encounter this event, that vertex. Okay, so similarly in the circle event also, okay, we'll come to that one. So whenever there is a change in the sweep line status, the beach line, whenever there is a new consecutive triplet appears in the beach line status or sweep line status, we will check whether these three sites going to define any circle event or not. How we can check? The circle passing through these points should intersect with the current position of the sweep line. If it intersects, okay, then in future, when the sweep line moves downwards, it becomes a tangent to the circle. So in that case only we will actually consider as an event, circle event, and we'll add it to event queue. Okay, this is one point. Another point here is, so before they came into the picture, there could be another site somewhere here, IJKL, say, okay. So before the PK is coming into the picture, IJL are three consecutive sites. And consecutive sites in the sense there's parabolas corresponding to these sites are consecutive in the beach line. So these three may define a circle. In fact, it defines a circle event. If you take a circle, okay, intersect with the sweep line. So in future, this sweep line become a tangent to this one, that where this middle parabola disappears. Okay, this is a circle event, valid circle event till this PK is coming into picture. But when the PK came into picture, okay, Pi, Pj, Pk no longer three consecutive in the beach line. I mean, consecutive in the sense, these points are not consecutive. Their respective parabolas are consecutive in the beach line or sweep line status. So because of the new PK, the three consecutive triplets is disappeared. So event corresponding to these three, that circle event corresponding to Pi, Pj, PL, won't take place. Okay, those things we have to remove or we should not process. That is one thing. Okay, when the PK came, what are the new three consecutive triplets? Here, Pi, Pk, Pj is one triplet. Similarly, Pk, Pj, PL is another triplet. So we have to find out whether these three are defines another circle event or not. So basically, whenever there is a change in this beach line status, by means of a new parabola coming into picture, first it destroys some three consecutive triplets, and circle event correspond to that. If already is there in the event queue, we should remove them or we should not process them. And this new parabola defines a new three consecutive parabolas, and we have to find out this triplet, circle event correspond to this triplet, and if it is going to take place in the future, we should add that circle event in the event queue. Okay, basically new parabola destroys some triplets and creates new three consecutive triplets. So which are destroyed, you should be removed, which creates, we add corresponding this circle event. Is this clear? Any questions? Hey, everybody convinced about this one or not?
Yes, sir.
See, if in this diagram, if PK is not there, parabola corresponding to PJ disappears after some time. So PI, PJ, PL defines a valid circle event if PK is not there. Because the PK is came and this new existence is destroyed and the circle event corresponding to PI, PJ, PL does not take place, it's a false alarm because of we don't know the future actually. We don't know the future point PK. Okay? Before PK it is a valid, but it is a false alarm as soon as PK is encountered. So we remove that one. And the PK also defines the new 3 consecutive pairs. Okay? In this case, PI, PK, PJ and PK, PJ, PL. Okay? So for each of these things, you see, it can define one more on either side also. Okay? So for each one of them, you see whether some new circle event is valid, circle event is there, the circle event valid, then you put it in the event queue to process this. Okay? So basically what we observed is we are finding some circle events, but a circle event, we are not guaranteed that the circle event takes place in the future or not. Okay? So for example, you have seen here PA, PJ, PL is a valid circle event, is not going to take place because of new site PK. So yeah, we are finding some circle events, but those may not take place in the future. Okay. Similarly, at circle event also, when the PJ is disappear, parabola corresponding to PJ disappears, then what happens? New 3 consecutive triplets will form. Okay. There could be some site, okay, left of PI. Okay, maybe something may be there. Okay, maybe right of PK, maybe something may be there. When the PJ is destroyed, here also we are getting a new 3 consecutive pairs. Okay, let's call this as a P1 and let's call it as a P2. When PJ is disappeared, P1, PI, PK is a new triplet. Similarly, PI, PK, P2 is a new triplet. And we have to check whether these 3 defines a new circle event or not. If it is a valid circle event, put it in event queue. So whenever a new parabola is added or an existing parabola disappears, we have to find out what happens. Okay, we have to find out which triplets actually becoming a invalid. We have to remove the circle event corresponding to that one, which are becoming a new triplets, and you will see whether they are forming a new valid circle event or not. If it is there, then you add them into event queue. Okay. Any questions? Okay, once we identify the events, what else there? We have to find a suitable data structures to maintain a beach line and event queue. And there will be a few implementation issues will be there, and those we will discuss in the tomorrow class. So I request everybody should go through this material, okay, and try to understand this algorithm. And yesterday I scheduled your seminars. Okay, so I scheduled during the weekdays only, class timings only. But I think 2 Saturdays I scheduled 4 seminars. Okay, and that we will decide maybe 10:30 to 12:30 we will have it on Saturdays. Okay, somewhere towards end actually I scheduled on Saturdays. So here your presentation is very tight. You have to give a presentation within your time slot. It is not possible to reschedule it. Since we are deciding these dates beforehand, okay, don't ask for any postponement or another chance for your presentation. Either you give a presentation, you don't present actually. You'll get a 0. Okay. Any questions? Okay, if there is no questions, we will meet tomorrow and we'll wind up this one-hour diagram.